All right, let's jump right in. Today, we are going to build ourselves a mathematical toolkit. Seriously, we're going to tackle factoring polynomials by breaking it all down into a few simple, super reliable tools you can use every single time. So, let's get started.
So, let's start with a question. Just look at these two things for a second. You've got the number 12, simple, you've known it your whole life, and then you've got this polynomial, which, might look a little more complicated. So what on earth could they possibly have in common? So let's start with a question. Just look at these two things for a second. You've got the number 12, simple, you've known it your whole life, and then you've got this polynomial, which, might look a little more complicated. So what on earth could they possibly have in common?
Okay, so let's lay down the blueprint for all of this. We're going to start with something we all get, factoring a basic number, and use that as a bridge to get into the world of factoring polynomials.
And this right here really shows you the big idea. On the left, we take 12 and we break it down into the numbers that multiply to make it, right? 3 times 4. Now look at the right. We are doing the exact same thing to the polynomial. We're just breaking it down into its building blocks. In this case, x minus 3 and x plus 4. It's the same idea, we're just using slightly different language.
And that's really the main takeaway here. Don't let all the letters and the exponents scare you off. Factoring, whether it's a number or a polynomial, is really just a search for the basic pieces, the building blocks that multiply together to give you the thing you started with. It's an old idea, just in a brand new context.
So now that we've got our blueprint, it's time to lay the foundation. Every good toolkit needs that one core rule, the one principle that everything else relies on. For us, that's what we're going to call the golden rule of factoring.
And here it is. It's officially called the factor remainder rule, and this is your absolute best friend. Think about it like this. If you divide 12 by one of its factors, like 3, what's the remainder? It's 0, right? Goes in perfectly. Well, it's the exact same for polynomials. This is how you check your work. If you divide a polynomial by something you think is a factor, and you get any remainder at all, well, then it's not a factor. Simple as that. This is the bedrock of our whole toolkit.
All right, it is time to grab the first real tool for our kit. Think of this one as our power tool. It's designed for a very specific job, but one that comes up all the time, factoring the sum or the difference of two perfect cubes.
Now, the first step to using any tool is knowing when to use it. For this one, you've got to get good at spotting perfect cubes out in the wild. So when you see a number like 8 or 27 or 64, a little light bulb should go off in your head, thinking, hang on, this might be a job for my cube factoring power tool.
Okay, now here are the formulas themselves. I know at first glance they can look a little intense, but there is a really cool, simple pattern hidden in the signs. Just look. The first little binomial, the a plus b or a minus b, it always matches the sign of what you started with. The next term, the ab part, it's always the opposite sign. And that last term, the b squared, it is always positive, no matter what. So just remember, match, opposite, always positive. That little trick makes these so much easier to handle.
Okay, let's grab tool number 2. This is the multi-tool of our kit. It's super versatile. We call it factor by grouping, and it is your absolute go-to method when you're looking at a longer polynomial, especially one that has 4 terms.
And here's how you do it. This method is amazing for taking a messy problem and making it orderly. First, you literally just split the thing in half. You group the first 2 terms and the last 2 terms. Then, from that first group, you pull out the greatest common factor, the biggest thing that goes into both of them. You do the same thing for the second group. And then, kind of like magic, you're going to see that the same binomial pops up in both parts. That's your common factor, and you just pull it out one last time. It's a really clean, logical process.
And just like that, you've done it. You have officially added 2 incredibly powerful tools to your mathematical toolkit. You are now geared up and ready to start building. So, let's do a quick check of what's in the toolkit. First, you've got your golden rule, the factor remainder rule, that lets you check all your work. You've got your power tool for handling the sum and difference of cubes. And you've got your versatile multi-tool, factor by grouping, which is the perfect solution for those tricky 4-term problems. So I'll leave you with this. We've just spent all this time putting together a toolkit. But what's the point of a toolkit if you just let it sit on a shelf, right? It's meant to be used. These skills, this is the foundation for solving way more complex equations, for really understanding functions, for building some incredible mathematical ideas down the line. So the real question isn't what we did today. It's now that you have the tools, what are you going to build?